All right, we are beginning a new chapter, chapter 12, and section 12.1 deals with inverse variation. Back in beginning algebra, we touched on direct variation. So, quick review of direct variation. The general equation for direct variation is y equals a times x, where x does not equal 0. So the inverse variation is where x and y show inverse, and the general equation is shown as y equals a divided by x, where a does not equal 0. So to start with, what I want to find is, this will help you with your assignment, is to tell whether um, each example is either a direct variation, an indirect variation, or neither. So if we look at A, what you need to do is first solve for y. So get y equals something. So to get this for A, we have to first divide by x. So that cancels, and that leaves me with y equals 7 divided by x. Now that looks a whole lot like an inverse variation. So I'm going to write down inverse, where A equals 7 in this case. So for B, I have x divided by y equals 2. So in order to get y equals, I need to get y out of the denominator. So I'm going to divide or multiply, I'm sorry, both sides by y, which this cancels, which now leaves me with x equals 2 times y. So now I divide both sides by 2, and this leaves me with 1/2 times x equals y. And this looks like a direct variation, where a here equals 1/2. Now let's look at C. C here, we're going to first, I want to get y by itself, so I'm going to subtract both sides by 3x, which now is canceled. So I got negative y equals negative 3x plus 5. I want to get rid of that negative with the y, so I'm going to switch all the signs. So now I have y equals 3x minus 5. And this is a case where it's neither. Reason is because if you look at the general equation for direct variation, there is no plus or minus attached to it. The inverse, there's no plus or minus attached to it. So we can conclude that it is neither an inverse nor a direct variation. Next portion of our assignment is being able to graph inverse equations. And just like when we had quadratics and graphings of square roots, we had an apparent function. Same thing goes for here. So here is how a inverse graph looks like when y equals 1 divided by x. Just like what we've done in the past, we made a t-chart, and we were given values for x, and we could then determine what y is by substituting those values for x into the equation. So if I gave random, so we got negative 10, say I had negative 5, say I had negative 1, 0, 1, 5, and 10. I just had those certain equations. So if I were to say plug in negative 10 in for x, I would get a negative 1/10 for y. I would get a negative 1/5 if I plugged in negative 5. I would plug in a negative 1. Now if I were to take 1 divided by 0, if you were to say put that in your calculator, you get an error symbol. So 1 divided by 0 is undefined, which that is considered an asymptote, and I'll talk about that in a little bit. So now if I put x in for 1, our y would be 1. If x is 5, our y would be 1/5. And if x is 10, our y would be 1/10. So if you look, I'm going to plot first, I'm going to plot negative 1 and negative 1 and 1 and 1. So I got 1 and 1 and negative 1 and negative 1. And if you look at the graph here, if it seems like if x is getting larger in the, it seems like our y would be getting smaller. So I'm going to make the assumption that our graph kind of looks like this, and coincide here. Same thing goes for when it's in quadrant 3. Apologize for my artwork. And that's kind of what the graph looks like when y equals 1/x. What this kind of graph is called a hyperbola. And if we were to then plot or graph y equals negative 1/x, well, all we are doing is we're just reflecting over the x-axis. So what was graphed in first and third quadrant will just be shifted in the second and fourth. And the domain and range here, the domain is the set of all of x values, and the range is the set of y values. It can be all real numbers as long as x does not equal 0. Same thing for the y. Y cannot equal 0 because, again, if x is 0, it's undefined. So that's where we get our asymptotes. And our asymptotes stem from, I'm really not sure why that is like this. Our asymptotes are lines that the branches approach but never intersect. So here the asymptotes approach 0 but never actually reach 0. So let's do some examples on graphing inverse equations, and then we can compare it to y equals 1/x and identify the domain and range. So here I have y equals 2 divided by x. So what I'm going to do is I just want to make a t-chart. And what I'm going to do is I want to first give me an x value of 2 and an x value of negative 2. Because this will give me my value of 1 and negative 1. Now I'm curious, I want my x to be 1 and my x to be negative 1, so then my y then would be 2, negative 2. And I'm going to plot these points. So I got 2, 1, I got negative 2, negative 1, I have 1, 2, and I got negative 1, negative 2. So these are going to help me draw my graph. And here, again, our domain and range is all real numbers. Well, the domain is all real numbers when x does not equal 0, and the range would be what all real numbers when y does not equal 0. And what we are looking for when it comes to the comparison of y equals 1 over x, we notice that it's what, 2 times is large. It's almost like it has like a 2 times stretch rather than the regular 1 over x. So that's kind of how you graph this one. For b, which is down here, I have y equals a negative 4 over x. So just like I did before, I'm going to make my t-chart, and I want to do negative 4 and 4, and I also want to do 1 and negative 1. So if I got negative 4 here, my y will be 1. With x being 4, my y would be negative 1. If x is 1, my y is negative 4. And if my x, is negative 1, my y is 4. So I'm going to plot these points. So I got negative 4, comma 1. Got 4, comma negative 1. And I have 1, comma negative 4. And negative 1, comma 4. And I'm just going to and that's kind of what the graph looks like. And that makes sense because it's a negative number, so it reflected over the x-axis, so that's why it's in quadrants 2 and quadrants 4. Again, our domain and range will be all real numbers. The exception would be x is not equal to 0, and then the range is also when y is not equal to 0. So I hope that helps. Last thing we talk about is we make the assumption that x and y vary inversely, and we need to write an inverse variation equation given the values of x and y. Then, once we do that, find the value of y when x equals 8. So we make the assumption that it varies inversely, so we know that it's going to work with y equals a divided by x. What we don't know is we don't know what the constant of variation is. We don't know what a is. So in order to solve it, we are going to substitute in these values and plug them into this equation. So my y equals 2. I don't know what a is, but my x is negative 6. So if I multiply, I'm solving for a, so I'm multiplying both sides by negative 6. That cancels. So negative 12 equals a. So the first portion of our problem, I know that my y equals negative 12 over x. That's the equation, the inverse variation equation that I need to define given that x equals negative 6 and y equals 2. So that's one answer. Second part of our problem is I need to know what y is when x equals 8. So what all I need to do is just substitute in 8 in for x, so I have y equals negative 12 over 8. And I can reduce this to negative 3 over 2. So when x is 8, my y is negative 3 over 2. Okay, let's look at b. So again, we're going to use our y equals a over x. And I'm going to substitute in a negative 1/2 equals a divided by 12. I want to solve for a, so I'm going to multiply 12 to both sides. Those cancel. Negative 12 divided by 2 is a negative 6 equals a. So my equation for is y equals negative 6 over x. Now so that's the first part. Second part is let's find what y is when x equals 8. So I'm going to go y equals negative 6 over 8. And this can be reduced to negative 3 over 4. And that is section 1 in inverse variation. Hope this helps. And until next time.